Hey guys, welcome to question FM337 of the Further Maths Fortify study guide. This question reads, Farmer Lou is trying to grow his crops. After a bout of bad weather, Lou decides to move his crops indoors and maintain them using artificial lighting. Lou plants his crops in a rectangular patch of length 2 meters and width 1 meter. Lou uses 2 lights to replace sunlight. The lights are placed above the crops. The center of each light is 1 meter away from the other and offset 0.5 meters from the edges of the rectangular patch. These lights radiate light conically at an angle of 60 degrees from the globe. This information is shown in the 2 figures below. Question FM337 then says, the edges of the circles made by the conical light coincide with the corners of the rectangular patch. The height of the lights, h in meters, is closest to what? So the first thing we want to do is build up a little bit of a model for how we're going to figure out this height, okay? So if we were to look at what's going on here, we've got a cone kind of shaped like this at 60 degrees, and our height is this dotted bit down the middle. So we can't figure out the, so actually we'll transfer this first. To make a more simplistic view of this, if we were to create a right angle triangle, we've got an angle of 30 degrees here, and h is going to be this adjacent side. So our height is going to be on the adjacent side. Now, we've got 2 options here. We can either try and figure out what this length here is going to be, which there's not much we can do to figure that out, or we can try and figure out what this length down here is. So we can try and figure out either of these lengths. If we were able to figure out this one, then we'd be able to use the adjacent and the hypotenuse, use cos with that 30 degrees to figure out h. If we can figure out this length, if we can figure out what x is, we can use tan to solve this, or if we can figure out what both these are, we could use Pythagoras theorem and forget about the 30 degrees, full stop. We're going to try and figure out x down here, and then use tan to solve this question. Now the reason that I've picked this bottom length down here, x, to work with is because we've been given information that makes it a lot easier for us to figure out what x is. So we've been kind of given this visual. I'm just going to draw the bottom half of it where we've got the center of the light above here, and it's casting light around, and that light is, the edges of that light I should say, coinciding with these corners here. Now what we know about the center of this light is that it's 0.5 meters away from this edge, and also 0.5 meters away from this edge over here. So these are both 0.5, which means if I wanted to break it down, I'd have a right angle triangle with sides of 0.5 and 0.5, and x, this length here, not to be confused with, remember that the edges of the container sort of work like this. So if we were to take x to have a value of 0.5, that would be incorrect, as it's going to be a little bit longer, because 0.5 is how far away it is from the edges of these boxes, but this corner is going to be further away from that central point. So we actually need to figure out this length here to figure out what x is. So the hypotenuse of this right angle triangle is going to be x, and of course we can use Pythagoras theorem to give x a value. So we're solving for the hypotenuse, which means we usually use c squared equals a squared plus b squared. I like the formula c equals square root a squared plus b squared better. So substituting our values into that, c is going to be x, and we should get x equals 0.5 squared plus 0.5 squared, which once we put all of that together and sort of simplify it down, we should get root of 0.5 for our value of x. Now we can go back to our original right angle triangle, where we have h, which is what we're looking for, our angle of 30 degrees, and we now have a value for x of root 0.5. From here we know that this is our adjacent side and this is our opposite side, so we're going to be using tan theta equals opposite over adjacent. Substituting our known values, we get tan 30 degrees is equal to root 0.5 over h. Rearranging this or plugging it into solve in your calculator should tell you that h is going to be equal to root 0.5 over tan 30, which solving for that should give you an answer around 1.22 meters, meaning that our correct answer is option C. If you guys have any questions about that, please drop them in the comments below. Otherwise, I'll see you in the next video.